Chapter 11, we're now doing chi-squared. That's not an x, it's going to be the letter chi. It's often written as chi square. And there's another idea of a life energy force, which is chi, but nope, we're using the letter chi, different alphabet. We're still going to have a null alternative hypothesis, set alpha. The method that I'm going to be using is going to compare chi-squared to a critical chi-squared. There is another method comparing p to alpha, which is what you're used to doing, but unfortunately some of you are going to be unable to do that. So that's why I'm going to ask everybody to do it this way, comparing chi-squared to critical chi-squared. And then, of course, you're going to make a judgment with respect to the null hypothesis. As for the work that you need to do, the formula for chi-squared, which you're actually going to have to know, is that you take observed minus expected, you square that, and you divide by the expected value, and then you add that up for each of the categories. Now expected, let's see. If I count up the number in each of these, 15 plus 28, that's 43, plus 11, that adds up to 54. Now that's what I observed. For the expected row, I'm going to take that same total, the same 54, but now instead of what we saw happen, we're going to write what we would expect to happen if everything was flat and homogeneous. 1/3 of 54 is 18. So if there was no pattern in choice of ice cream, I would have expected the same number of each. Well, I say expected, that would actually be a little bit unexpected. It's kind of like flipping a three-sided coin and getting the same number on each side. It can happen, but it should be rare. The distribution for chi-squared is going to be different from the bell curve. Note that it is possible to have observed and expected line up exactly. So that is a possibility, but it should be rare. A little bit of variation is what we would expect. That would be what is most common, a little bit of variation. More variation? Well, not that rare. But eventually there's so much variation from what we expect that it ends up being more reasonable to say that there really is a pattern in ice cream flavor chosen, that it was just too different from the flat distribution. Now, to find out where to reject, we're going to have to go to one of the tables. This is from the tables that I emailed you. I've also posted it under instructor resources to my stat lab. It's the last one, table A4, and it's the chi-squared distribution. Area to the right of the curve. Now, over here, those are going to be values that are quite close to the left side, where most of the area is to the right. These are used mostly for fraud detection. When people make up numbers, the numbers tend to be too close to what you'd expect. They aren't strange enough. You expect a little bit of strangeness in life. Over here, we have values that start being too strange to be believed. So, not strange enough, too strange. If you'll recall, we set alpha equal to 0.05. So I'm going to concentrate on this column. For degree of freedom, The degree of freedom is going to be the number of categories minus 1. So in this case we had 3 categories: vanilla, chocolate, strawberry. 3 minus 1 is 2, so that will be your degree of freedom. If you see where these cross, that happens right there at 5.991. So that's going to be your critical chi-squared, and you're going to have to find it out by looking it up on a table. So my critical chi-squared is 5.991. My actual chi-squared, well, it was observed minus expected squared over expected. You'll notice that expected in each case is 18, so I have a common denominator of 18. The numerator is going to be the difference squared. The difference between 15 and 18 is 3, squared becomes 9. The difference between 28 and 18 is 10, squared becomes 100. The difference between 11 and 18 is 7, squared becomes 49. So on your calculator, let's see, open parenthesis, 9 plus 100 plus 49, close parenthesis. That forces the numerator to be added together, and then you divide by 18, and that's going to be your chi-squared value, 8.7 repeating. Now chi-squared is a test statistic, so we like it to 3 decimal places, so 8.778 would be our chi-squared value. Now, if we return to this picture, if 5.991 is our critical chi-squared and 8.778 is, well, much further out, it's in the zone of rejection. So what we're looking for is when chi-squared is greater than the critical chi-squared. That's when we're going to reject. Since 8.778 is greater than 5.991, we will reject the null hypothesis. Not that I've told you what the null hypothesis is. I've left that because it's going to be in a different style from any of the others that we've used. We have been saying things like p is 0.08, or mu is 32, or rho is 0. Those have been some of the hypotheses that we've been using. They've all been, well, some sort of formula. For chi-squared, they're actually going to be short sentences. In this case, my null hypothesis is going to be there is no pattern in ice cream flavor. Just for this descriptor, pick out a way of differentiating between vanilla, chocolate, and strawberry. The alternative hypothesis is going to be such a pattern exists. And I make that my alternative hypothesis for all of these. It's a slightly different style from the book, just enough to be annoying. My apologies. Now, lastly, comparing p to alpha. It can be done by most of you. So, back to the calculator. Stat, edit. You'll notice that in list 1, I've put 15, 28, and 11. That's my observed value. In list 2, I put 18, 18, and 18. That's my expected value. Next, I go stat, tests, and it's easiest if you go up. I'm going to go up to chi-squared goodness of fit test. And at this point, many of you are going to be disappointed. It's typically not found on the TI-83s. It's not found on all of the TI-84s. So some of you will have it, some of you will not. That's why, to be fair, I'm making everybody do it the critical value method. But if you want to follow up and do it with this method, that's fine with me, and it will be helpful for the next workbook problem. So, I hit enter. I put into the observed list 1, expected list 2, and I list my degrees of freedom, which does happen to be 2. And I calculate. So do you see that they say that chi-squared is 8.7 repeating, just as we did. Frankly, I don't think entering all of the numbers into the list and then doing it with the calculator is really any faster than doing it by arithmetic. The arithmetic in this case is simple enough. It also lists where the contributions come from. So do you see this 0.5? That's actually 9 over 18. This 5.55, that's 100 over 18. So it lists which are contributing to the chi-squared. So it looks like chocolate contributed most of the difference. Vanilla, very little difference. Strawberry, a reasonably large amount of difference. 49 over 18 sounds like it should be about 2.5. But the value I'm going to look at here is the p-value. P is 0.012. That is less than 0.05, which is your alpha. So the one thing that chi-squared GOF test allows you to do that I wasn't able to do without it is find this value of p.